Okay, boys, I'm going to do a parabola as a sectional view of a cone. Now, this is slightly different to the other two things we've done before. So first of all, I'm going to draw the parabola. So that there is our cutting plane. Okay, so how we go about doing this is pretty simple. We divide the circle up into 12 equal parts, like we've done 1,000 times before, using our 30, 60 degree set square. We draw the generators. Okay, so each of them generators will have a value. Okay, now, so we're going to bring them generators up to our elevation. Now, I hope you can see that clearly. And we create them generators in elevation by running to the apex. Okay, now, so what we do then is where they hit, where our cutting plane, so our cutting plane hits there, 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 and there. Now it's fairly simple. As it says before, you bring this point down where it hits the first generator, so we know that it's the extreme generator, so that's that one. This one here hits the next two, and this one here hits this generator here and this generator here. Now when we bring that down, that'll just be along the straight line. So what we have to do is we bring this down out to the extreme generator where it hits it. We drop it down and we swing it around. And the last point, it doesn't hit any more generators, so it hits the edge of our cone. Now, this is a sectional view. Okay, that doesn't give us a true shape of our parabola. So how would we go about doing that? Well, we would project it down and take their widths out. So we go at 90 degrees to our cutting plane, which I have at 60 degrees there for ease and use. And I bring them points out and I draw a central axis. And obviously the first point is here. So the next point would be the distance from here out to here. So we step them out there and there. Then we go out on the next one. We go out on the next one. And finally, it hits our edge of our cone at that point and that point. Now, that will allow us to create our true parabola. Okay, so I hope that makes sense. Now, okay, if I was asked now to establish where the focus would be and the directrix, so how would we do that? Well, very simple. because it's a parabola, we know that the center of it must be across from where it hits our extreme generator, because that there is our vertex, V. So what we would have to do then is draw a semicircle, but again, the simple version of doing that there is we draw a line out of 30 degrees, so that's 90 degrees to the extreme generator. And we can put it in our focal sphere. Now, so as I said, where our sphere hits our cutting plane, that is our focus. Okay, and then remember from our previous video that we would draw a line through where our sphere hits our cone, and that would give us our directrix, D. So we would have to bring F down to get our focus, F, V, and we'll bring this line down, and that would give us our directrix. Okay, now again, if any of any questions, so how do we, I'm gonna again illustrate a point that if we do this correctly, so I'm going to use the furthest point out here. Okay, so if this is correct, which it should be, okay, this here should create a circle, because the distance from the focus to a point in the curve and the directrix to the point in the curve should be equal distance. And as you see, because that creates a curve, that tells me that that point and that point are equal distances away from that point on the curve. Okay, now if I want to draw a tangent to that point on the curve, I draw a line from the focus, a line perpendicular to the directrix to the point. So as you can see, that's 90 degrees to the directrix. Okay, we draw a line from the point to the focus, and to draw our tangent, we bisect that angle. So we can do it whatever distance we want. And that will help us create a tangent to the point P from. Okay, so that's a tangent. To a point P on the curve. Now the important things to remember here is it's 90 degrees to the directrix, and it's a straight line from the focus to the point in the curve, any point in the curve. So if you divide the angle or bisect the angle between the focus and the point on the directrix, you will be able to get the tangent. I hope that makes sense, and thank you.